Okay, so let's start with the guessing first. Okay, and this is really good, right? So in the math class, you may not be used to guessing because there's always a precise answer, but practically speaking, guessing is very important. You can call it guesstimate if you like. Okay, now the smaller room is 10 by 12, and you realize that what you have to compare is, of course, the floor size in square feet. 10 by 12 will give you 120 square feet. All right, and this larger square room, 15 by 15, is 225 square feet. And so that means this bigger room will probably be twice as much, right? 120 times 2 is 250. This is close to 240. This is close to 240, so almost twice as much. And that would be then about 800, twice as much as 1600. But not quite, right? So you can guess that it'll be slightly less than $1,600. Yeah, that would be a great estimate. See, this is important because if somebody came up and said, well, it's going to be about, 3,000, and the person says, oh, look, I'm good at math. The answer is going to be 3,000. And you say, no, that can't be right. So guessing, estimate, even if you don't know the correct answer, it may be a great way to be able, it's a great idea to be able to estimate fairly accurately. Okay, so your guess is like, little less than 16,000, and that would be a great guess. All right, now the proportion is the precise way of solving this. And here's what happens. You're going to spend $800, right, for a 120 square foot room. So then that's a fraction. So this will give you basically dollars per square foot. And so now you don't know what the answer is. Let's say the cost is something, okay? And if you don't like to use C because it looks very much like algebra, you can put a question mark, okay? It's up to you. You can do, let's see, where's my ink? Yeah, okay. So this is a question mark because you don't know how much it is. Divided by, what is that? 225, right? Now, here's the thing about proportion. Once you set up two fractions, okay, which are the proportion, this is what we call proportion, two fractions equal to each other. Then, and you may remember this, you can do cross multiplication because fractions are equal if and only if the cross multiplication results in the same amount of same number. All right. So what you're saying is 120 times the question mark, that's his multiplication, is equal to 800 times 225. Okay, and you can go ahead and calculate 800 times 225, but in order to get this question mark, remember this side is multiplied by 120. So what you have to do is to take this number, the product, and divide it by 120. Okay, so 800 times 225 divided by 120, and that is equal to, and this is how you calculate your answer. It turns out to be 1,500 precisely, or exactly, okay? So the answer is 1,500. Does it sound reasonable? Yeah, because it's very close to our guess, which was 60 or less than 1,600, right? So that was a good guess, and the answer is 1,500. Now you will be doing a calculation like this quite often in the exercises from this section or from these sections that are covered by this lesson. And now, if you need extra help, and I realize that some people may need extra help with fractions or decimals, this kind of a question, proportion, you can actually sign up completely free, all right, for our non-credit course. This is sort of new. We haven't had non-credit math classes for a long time at College of the Canyons, but currently you can take non-credit. If you go to the schedule of classes, just go to NC non-credit math courses, not math courses, but non-credit math courses, and you can find a course called NC Math 001 to 008. But the fifth of the course, that's 005. It's a mini course on proportions, right? Open entry, open exit. You can sign up for free, and you will have an instructor that you can ask questions. You will be learning this on your own pace by answering questions, watching videos, doing exercises, all online on your spare time. And so this will be a great way to supplement your learning, okay? And again, this is an extra form of support that we have created. So I hope you take advantage of these. And even though these are courses, you don't have to stay in there for the entire semester or even for weeks. You know, you can just, as long as you do all the problems and if you're happy, you can just, you know, leave, or you can finish the entire course in a matter of days. All right, so on the second page, let's go to just guessing again. All right, so again, as I mentioned, guessing is a pretty important thing. It'll just tell you sort of a ballpark figure of what the answer should be, right? So here's a question. It takes 2 hours to fill a 20 by 40 pool. Sounds familiar? Right. Then how many hours approximately would it take to fill a 40 by 30 pool? Okay, assuming that the depth is the same. So estimate an answer, right? So what is that, 20 by 40? Sorry, 20 by 14. That is 280 square feet, right? While the bigger one, 40 by 30, that's 1,200 square feet. So how much bigger is that? Well, if you compare two, all right, so 1,200, half of that is 600. 1/4 of that is still 300. So this is 4 times as big, or you can say it's more than 4 times as big. Okay, so assuming, again, that the depths of the pools are equal, it'll take you at least 4 times more. It is 2 hours, so it'll be probably more like 8 or 9 hours, right? And oftentimes, this is enough for you to sort of, you know, figure out approximately, because you don't really need to know the exact number of hours, right? Now, if you want to do that for to find the precise answer, then you will do what we just did, the proportion, okay? So how do you do that? Well, 200, well, so you have 280, you divide it by 2, so that would be actually 140, and that is the number of square feet that it can be filled by 1 hour, right? And that's equal to 1,200 times, we don't know what, right? We can call it H for hours, T for time, I'll just put question mark, right? Cross multiply, so 280 times the question mark is equal to 1,200 times 2. Question mark then can be obtained by dividing this product by 280, okay? So if you can do this, you will find the answer is 8.57 approximately, okay? You can round off at any reasonable point. In this case, you can say it's about 8.6 hours or 8.5 hours. And so that is the answer, which is good, right? I mean, this is consistent with what we guessed in the first place. Okay, this guessing idea is also fairly important. So here's another question involving large numbers. How much is $45 billion plus 5 million? So assuming that a rich person is worth $45 million and he or she has just earned some extra money, $5 million. How much is the total? Okay. Of course, the precise answer, a boring answer, is 45 billion, 5 million. That's, you can't argue with that. Okay, but you realize that the sum is pretty much about the same as 45 billion? Yeah, it is. All right, so the answer is this, approximately 45 billion. And so what do you mean? You got extra 5 billion? Yes, but in light of the 45 billion, this number is so small that it's negligible. That's what we need to understand, right? So these large numbers are hard to grasp, but sometimes a large looking number is so much smaller compared to a larger number that it is negligible in light of the big number. Okay, so that is something that you may want to consider. And this is significant. Like, for instance, let's say a country has 1 billion people, and let's say lots of people died of a sudden and unexpected natural disaster like an earthquake or something. So let's say 1,000 people died, or 10,000 people died out of 1 billion. How many people surviving? And the answer is pretty much like 1 billion. Okay, because I don't want to say the number of people insignificant, but the number like 100,000 is so much smaller compared to 1 billion that even if you take away 100,000 from a billion, you will still end up with close to a billion, right? And here's another interesting question that we will come back to later in this course in counting and probability and so on. If you have a 10-player lineups, okay, like in Major League with a designated hitter, you have 10 players that are on the lineup, starting lineup of a baseball game, okay? And if you are the manager of that team and you know which 10 players will start, okay? Now, in how many ways can you order them in a lineup? Okay, and so it turns out, again, you will study this later. You don't really have to understand everything here. But for the number 1 player, for the first name on the list, you have 10 choices. Okay, and once you choose one of those 10 players, you have 9 people left for the second place, right? We call it the 2-hole or the second in the lineup. There are 9 choices independently. And then after that, you have 8 to choose from for the third place and so on. And so it turns out the answer is you multiply all the numbers from 10, 9, 8, 7, all the way down to 1. Okay, and this last one for the 10th position, you basically have only one choice because there's only one player left. Right? This number is actually called 10 factorial. We denote it with an exclamation mark. Okay, not a big deal, right? So, I mean, like how many possible ways can a manager order 10 players on the lineup? It turns out if you multiply this turns out to be surprisingly a large number. And that's why we use this exclamation mark. This number turns out to be more than 3.62 million. This is approximately, the wavy lines means approximately. Okay, so that's, wow, this is a big number. Okay, it turns out these things are called permutations. The number of permutations turned out to be very large. All right, so speaking of baseball, let me just give you a context of this story here. Right, a lot of times when sports and athletes and their organization, like the Major League Baseball Players Association and the Major League Baseball or basketball, NBA and the players or whatever, when they are starting to argue and when they are trying to negotiate, their contract, people say, well, that's like, the millionaires against billionaires. The billionaires are the owners of these teams and millionaires are the players. Rich against the rich, who cares who wins, right? And so I want you to think about this. This is a great, great illustration that I want you to remember for a long time, maybe for the rest of your life when you talk about millionaires and billionaires, okay? Some are millionaires and some are billionaires. What's the difference? Okay, great question. Suppose you can earn $1 per second, okay? That means $60 per minute, $3,600 per hour, okay? Around the clock, 24/7. So every second, you can earn $1, exactly $1 per second, okay? Again, $3,600 per hour. That's not a bad hourly wage. Every day, 24/7. Okay, how long would it take you to become a millionaire? In other words, how long would it take you at this rate to earn $1 million? Okay, can you figure this out? And you can do all that unit analysis like we did on front page, or you can just simply divide. All right, so you have $1 million. If you divide this by 60, that would be, well, let's see. When you divide by 6, let's see, 60. This will be number of seconds in an hour. So this will give you the number of hours it'll take you to get to a, so let's go back here. If you divide this by 60, it'll tell you how many minutes it'll take you to be a millionaire. If you divide this by 60 times 60, which is the number of seconds per, my computer has a slight delay here, okay? So let's think about this and what do you have to divide by? Well, it's hard to know because we don't know exactly if it's in days or weeks or months or years. So here's what you have to do. Okay, so the first thing you do is just say million divided by 60, and that's going to give you a number of minutes, and then divided by 60 times 60, that's the number of hours. And you'll still see that that's a pretty large number. So then you multiply, well, you divide 1 million by the product of 60, 60, and 24. Now, the denominator here, this is the number of seconds per day, number of seconds per day. Because 24 hours per day, right? And so this will give you a pretty reasonable number, 11.574. Okay, so the answer is it takes about 11 and a half days. Okay, now again, the denominator is the number of seconds in a day. So it'll take you 11 and a half days to become a millionaire at this rate. Sounds good? Yeah, it sounds really good, right? Okay, in 11 days, you will have $1 million. So it takes, a little more than a week, less than 2 weeks to become a millionaire at this rate. Here's a question. With that rate, now that you are a millionaire, okay, after 11 days, 11 and a half days, how long would it take you to become a billionaire? Okay, another 11 days, whatever. Well, here's what you have to do. For a billion, of course, it's 9 zeros following 1, right? So it's 1 billion, and then you can go ahead and divide this by, again, 60. That would be the number of minutes it'll require you to be a billionaire. This number is so huge, you don't know how to comprehend it. 60 times 60 will give you the number of hours. 60 times 60 times 24 will give you a number of days. That's still a large number. So then you may want to divide this by 365, because now, I mean, this whole thing is the number of what? Here, this is the number of seconds per year. Okay, so when you divide 1 billion by the number of seconds per year, it'll give you how many years it takes to be a billionaire. And that turns out to be 31.7. Did I do this right? I mean, does it sound incredible to you? Yeah, but that's true, okay? It turns out it only takes you less than 2 weeks to become a millionaire at this rate. But at the same rate, it takes you over 31 years to become a billionaire. Okay, so now you have maybe a renewed appreciation for the billionaires of the world. I mean, there are lots of them. I don't know any of them personally, but you see the difference here? I mean, there is a huge difference between a millionaire and a billionaire. This is called number sense, right? Try to understand these large numbers in terms of something that you can understand, like the number of days and number of years. And that will help us really understand. If you're trying to communicate large numbers, this would be a great way to compare billionaires and millionaires. Okay, if you're trying to convince people that there is a difference between a billionaire and a millionaire, that would be a good way to understand this. Okay, so finally, let's just do a little geometry. You don't have to memorize any formulas, but I do want you to know some deceptive, maybe misleading facts about geometry. For a square or circle or any kind of a two-dimensional object. Okay, so here's a pizza. You can see a 6-inch pizza and a 12-inch pizza, right? How much bigger is that? Yeah, the ratio, or the diameter is twice as long here, right? How much bigger is this pizza? Well, if each side or a dimension like radius doubles, then the area quadruples. Quadruples. I think it's supposed to be U. Right? Okay, so that's surprising, right? And that's because 2 times 2 is 4. In two-dimensional thing, doubling in 2 dimensions, okay, will give you 4 times as much. So what I'm saying is that this 6-inch pizza, 12-inch pizza here, this thing is 4 times as big as the first one, all right? Even though you may be thinking that this is just twice as large, okay? So if this is, let's say if this is $10 and if this is $20 or something, okay, then this is a bargain because you're getting 4 times the size for the price that's twice as much, right? So keep this in mind. These things are crucial. And by the way, this is the way it is, right? In real world. For something big, they charge you just a little more, like in Starbucks. That's the next analogy or illustration. Okay, so for a solid, this is now a three-dimensional object. Okay, so for these, things are slightly different. All right, so when you're talking about three-dimensional things, you're talking about the volume. If each side doubles, all right, so think about this. Here's one little cube, right? And if each side doubles, what you're talking about is basically having two here and another one back here like this. Oops. Okay, that's so far I have 8 of these things, and then the height also doubles, right? So then you can see you have this is not a very nice picture here. Okay, but I hope you can see that you're looking at something that is ugly. All right, maybe this is a better way to do this. When you double the length and the height and the width, okay, you end up with 8 times as much, 8 times as many cubes, right? So the volume actually becomes 8 times. That is kind of surprising, right? But then we sort of get deceived by this. And I'll just mention this in just a minute. For any solid, each side, if each side increases by X%, okay, let's say 20%. This is kind of tricky, let's go ahead and not do this. Right? So let's say X is 20. If each side is increased by 20%, so you have a bottle of water here, and let's say this bottle is just 20% bigger. Then what that means is the height used to be 1, the height now is 1.2, right? 20%. And so the diameter also becomes 20% bigger. Everything becomes 20% bigger. Then, because it's three-dimensional, this is what you will get for the new volume compared to the first volume. Okay, so by making each dimension 20% bigger, the volume actually becomes 72% more. That's surprising, right? How about if X is 40%? Then 1.40 cubed, which is multiplying that by 3 times, and it'll give you 2.744 times as big, as large. Okay, so if you have a drink, and if you have a drink that, so here's an example. Let's say you are given this cup, man, that looks very much like, there should be a green circle here. Okay, but if you multiply, and this is, this is not as 6 to 9, but if it's 40% larger in every dimension, then the new cup is going to be 2.744 times as big as the original. And so you'll be drinking at least twice as much coffee, close to 3 times as much coffee by using this large cup rather than the smaller cup. Okay, that's sort of deceptive. Now, of course, you can calculate this. In this specific example, from 6 to 9 is 50%. You see that? Because the difference is 3, right? 9 minus 6 is 3 inches, and 3 inches is exactly 50% of 6 inches. So here, the volume will be 1.5 raised to the 3rd power, and that's 3.375 times as big. So this large cup contains, let's say if it's coffee, it contains more than 3 times the coffee in a smaller cup. That is surprising. All right, so next time you go to your coffee shop, favorite coffee shop, you may want to just order a large size if you're looking for value, because certainly this is not going to cost you 3 times as much. Usually it costs you like 50 cents extra or something, right? So it is geometry, and this could be deceptive, because you don't think about the big difference like this, but that's what the math shows us. Okay, at this point, we are finished with chapter 2. You can go to the worksheet for lesson number 6. And that is the last worksheet that you need to complete before your test number 1. So let's see, hold on a second. Okay, so we've had 6 lessons so far. I hope you have been able to watch all the videos and complete all the 6 worksheets. Remember, 1 worksheet for each lesson. So try to finish them, and then I will have a practice test number 1 ready for you so that you can get ready for your test number 1. All right, I will talk to you later. See you.